Okay, I'm recording it and we'll scan it and post the filled out ones. So let's look at the next one. The next one, ASA. This stands for angle, side, angle. Angle, side, angle. So the thing that's important here is that the side that's congruent, the corresponding side, has to lie in between the two congruent angles. So angle, side, angle. So when I look at the next triangle, I don't really know how it's orientated, but I'm going to go it this way. Angle, side, angle. So I always draw pictures of right triangles. That's how my brain works. It's just easier for me to see. So if I said angle, side, angle, next triangle, angle, side, angle. So I'm going to call this triangle X, Y, Z, triangle P, Q, R. So triangle XYZ is congruent to triangle PQR by angle, side, angle. If you can't use angle, side, angle if the congruent side does not lie between the two congruent angles. Do you guys remember that from Math 2? Hopefully you did. This is the same foldable or graphic organizer we used in Math 2. Okay. Angle, angle, side. Angle, angle, side. So this one means that you have two angles and then a congruent side. This one is different than the one before it because the congruent side is not in between the two angles. Congruent side does not lie in between the two congruent angles. So angle, angle, side. Angle, angle, side. So A, B, C, D, E, F. So triangle ABC is congruent to triangle DEF by angle, angle, side. Okay. HL is special because this stands for hypotenuse leg. And the only time that you have a hypotenuse is if you have what kind of a triangle? Yeah. So this only works if you have a right triangle. You need a right triangle. You got to say you have a right triangle. Okay? You got to say it's a right triangle in order to use hypotenuse leg. So what does hypotenuse leg looks like? Well, here's a hypotenuse congruent to another hypotenuse. Here's a leg congruent to another leg. So I'm going to draw two separate pictures. Again, I'm going to mark the hypotenuse and the legs. Let's call this J, K, L, and M, N, O. So triangle J, K, L is congruent to triangle M, N, O by hypotenuse leg, and we just say HL. I don't you can tell if that's an H or not, but it is, I promise. HL. Okay. And then you have side angle side. So side angle side means that the angle, the congruent angle, lies in between the two congruent corresponding sides. So this is side angle side. Okay. So I have just assigned a Delta Math to you. You can either go into Delta Math or not. I'm not taking it for a grade. I'm not taking it for a grade. It's called Intro to Proofs. You have a Delta Math proof assignment that we're going to have to do. So I don't know if you want to get into this one or not. It doesn't matter, like, because I'm going to do them with you, but it's going to help us come up with our statements on the back side. Okay. So I'm going to go to that Delta Math assignment. It's called 5.2 Intro to Proofs. 5.2 Intro to Proofs. Yeah. Yes. Can you give me one hot second? Can you see it? All right. So zip it, guys. I cannot talk over you, so you just need to shut it. So I'm going to go to that intro to proofs, and we're going to do some of those triangle proofs together. So flip your page over, your blue sheet that we just did together. And we're going to talk about some proof statements, things that we can say. Okay, so the first one, triangle congruence flowchart proof. Are you done with looking at that? So here's your first proof. So we're going to draw this diagram, because the more information you put on here, the more helpful it's going to be. So we're going to draw this diagram on your little picture on the back side of your notes. You're just doing a sketch and labeling it A, D, C, B, and make sure that you mark the same things congruent. So I'm going to split my screen so you can see what I'm asking you to do. So over here, where it says diagram, I'm going to draw this. I'm going to just draw this sketch. It's not going to be perfect. This is A, D, C, B. This angle is congruent to this angle, and then this angle is congruent to that angle. Okay. Do you guys see what I'm asking you to do? So it says, based on the given diagram, complete the flowchart proof below. Well, angle BAC, that's this angle right here, and angle DCA, well, that's this angle right here, angle DCA. The middle letter in the name of the angle is the vertex. Says that they're congruent to each other. Well, why are those congruent to each other? Well, because it's given. It's given. They're marked that way. Yes or no? Are they marked congruent in the picture? So it's given. Okay? Does that make sense? Okay, you're jumping ahead. We're going to say that the triangles are congruent using one of those theorems that we just learned. Okay? What about angle B and angle D? This is angle B, and this is angle D. Those are congruent to each other because they are given. They're marked for us in the drawing. Given. Okay? Segment AC is congruent to itself. It's the reflexive property. Here's how I want you to remember the reflexive property. The reflexive property is your reflection. It's the same thing, right? Something equals itself. Something is congruent to itself. That's the reflexive property. Okay? So now look at what you have. You have angle, angle, side, angle, angle, side. So now you can say that triangle ABC is congruent to triangle CDA. The reason? Angle, angle, side. Angle, angle, side. So we're going to put those statements right here. So angle BAC is congruent to angle DCA. What's the reason? Given. Angle B is congruent to angle D. What's the reason? Given. Segment AC is congruent to segment AC. What's the reason? Reflexive. And I just abbreviate it, reflex prop. And then the last thing we said, triangle ABC is congruent to triangle CDA by angle, angle, side. Okay. All right, let's do another one so we can get a couple of things filled out on our. So let's do a short proof. No triangle congruence. So it is given that segment BC is parallel to segment AD and that segment AB is parallel to segment CD. We have to prove that angle B is congruent to angle D. So the first statement is given. What shape is that? So what? What is the definition of a rhombus? A diamond. Okay. What is specific about the sides? All sides are congruent. Are those sides all marked as congruent? No, they're not. They're marked as parallel. Yeah. So this is just a parallelogram. That's the only information we have. We don't know anything about the lengths of the sides. So let's say that it's a parallelogram. Let's say that it's not going to let us say it's a parallelogram. No quadrilateral. Oh, no quadrilateral properties are allowed. Okay, that's fine. Well, we can say that these are congruent by alternate interior angles. So angle C is congruent to angle BCA is going to be congruent to angle. We're not doing this one. This is going to take way too long. Okay, CPCTC. Let's do this one. This is on the front of your little chart. You guys learned this in math too. Corresponding parts of congruent triangles are congruent. So, prove that segment JH is congruent to segment VX by filling out the flow chart. So let's draw this one. This is a good one. So we're going to draw this image. So I have a right triangle, W, X, V, J, H, I. My hypotenuses are congruent, and I have the legs congruent. So for each box, choose a statement. Format from the drop-down menu. You will then be able to change the letters and make it match. So what do you want to say first? Can't use hypotenuse leg unless we say that we have what kind of triangles? So let's say that we have right triangles. Okay. Can we do that? Let's classify our triangles. So how about VWX and JIH? VWX and JIH are right triangles. Reason given. Okay. Whoa. Who said CPCTC? Okay. What are we going to say next? Are the two triangles congruent? Yeah. Why? Well, we probably have to say this. We have to say these statements. We have to say that VW is congruent to JI. So segment VW is congruent to segment JI, given. We have to say that segment WX is congruent to segment IH, also given. And then we can say that the triangles are congruent. Triangle VXW and triangle JHI by hypotenuse leg. Do you guys see that in there somewhere? Because I cannot see it. There we go. Got it? Yes or no? Okay. So now we're trying to say the last statement, which is that JH is congruent to VX. Well, we can say it. JH is congruent to VX. Ooh, probably those should be capitalized. I don't know why they're not. By CPCTC. Corresponding parts of congruent triangles are congruent. Okay. All right. All right. Move on to the pink sheet. You guys should have a pink sheet. It looks like this. Quadrilateral proofs. Okay. So these are directions on how to prove that you have a quadrilateral. So to prove that your quadrilateral is a parallelogram, you can prove that both pairs of opposite sides are parallel using slope. You can prove that both pairs of opposite sides are congruent. You can show that one pair of opposite sides is congruent and parallel. You can show that the diagonals bisect each other, which means they have the same midpoint. You can show that both pairs of opposite angles are congruent. Okay? So this is probably something that we're going to put into our journal. But we're going to do the proofs on the back together. So this sheet looks like this, and mine's upside down. Okay. So I want everyone to go to this sheet right here. Please and thank you, gentlemen. Shut your mouth. Thank you. Okay. So in each of the, I don't know why that's not working for me. All right. So let's look at this picture. Under each boxed statement of the proof, write what you can make a conclusion about that is a true statement. So the first thing that we're going to do is mark up our proof. Whenever you do a proof, you want to have a piece of paper or dry erase board out so that you can copy the image. Because the way that the proofs are, like the pictures up here and all your statements and stuff are down here, and you keep scrolling back and forth, you just want to be able to look at the picture. Okay? So it's given that angle H, which is this angle right here, is congruent to angle E. Does everybody see that? Mark it. Mark it so on your paper. Grab a highlighter. You got those in your buckets in front of your feet. I mean, grab a colored pencil, do something. You also know that segment UR, which is this little piece right here, is congruent to segment US. Okay? So really, we have two pieces of information about these two triangles, the ones that kind of look like a bow tie. Do you see how these two triangles kind of make a bow tie shape? Yes or no? No? Yeah? Yeah? Okay. So, yeah, I see it. Okay. So here's our little bow tie shape. So I know that it's got a congruent angle and it's got a congruent side. We learned something last year about when two lines intersect and make an X, they create special angles. Their name begins with a V. Vertical angles. And we know that vertical angles are congruent. So we're just kind of thinking it out. But that's going to be the next logical statement. So let's see. Angle H is congruent to angle E. Well, that's given to us. So let's write given. For Petey's sakes. Come on. Given. And segment UR is congruent to segment US. That is also given. Angle HUR is congruent to angle EUS. Well, imagine that. We already marked that. Why did we say that? What kind of angles are those? Vertical angles. So vertical angles are congruent. Vert, angle symbol, congruent. That's the reasoning you need. Vertical angles are congruent. So what does that tell you now? Well, it tells you that triangle RHU and triangle SEU are congruent to each other by what? What theorem or postulate to say those two triangles are congruent together? Say what? Angle, side. The congruent side is not in between the two congruent angles. So it's angle, side. That's my reasoning. Angle, side. I can tell I'm boring you guys to death, and I apologize, but okay. You'll be all right. So HR is congruent to SE. Segment HR is congruent to segment SE. So this triangle right here is congruent to this triangle right here. And now we want to say, well, if that's the case, then this leg is congruent to that leg. And why is that? Corresponding parts of congruent triangles are congruent. CPCTC. I taught geometry forever. Okay. Are we ready to move on? Yes or no? Okay, next one. In each box, make sure that there is a true statement that follows a logical argument. So our proof, again, you want to start off with what's given. Mark it on your picture. Angle UQA is congruent to angle DQA. So where are we marking those? Where is angle UQA? At Q on the bottom. And angle DQA is at Q on the top. And angle DAQ, ma'am, is congruent to angle UAQ. Why are we able to mark those like that? Well, that's just given. It's just given. So both of these are given. What's the next statement? Is there anything that's shared between those two triangles? What? QA, and it's a segment. So we put a segment bar over the top of it, is congruent to QA, reflexive, and I just abbreviate it reflex prop. Reflexive property. Okay. So that piece is congruent to itself. So now how are those two triangles congruent? What do you have marked on those two triangles? You have an angle and a side and an angle. So triangle QDA is congruent to triangle QUA, QDA, QUA by angle, side, angle. Well, if that's the case, then angle U and angle D have to be congruent to each other. Notice that angle U is in the middle and angle D is also in the middle. The way that you name the triangles, the corresponding parts are in the same position, and that's how you know you've done that right. So angle U is congruent to angle D. Corresponding parts of congruent triangles are congruent. Okay.